These notes are on solving systems of linear equations using substitution. You've actually done a few problems back in Module 4 where you use substitution, and now we're just sort of adding a layer to it. So we have solve y equals 3x minus 2 and 2x plus 3y equals 5. So we have two equations. They're lines, they're linear. If I graph them, they intersect in a point, which means I need an x and a y value, a point. So I'm going to have to solve for both x and y. So the first thing I see here is that y is alone, which means that I know what y equals. It equals this thing. It may not be a single number, but it is something. So I take my second equation and I rewrite it, but I don't put the y in. Instead, I leave a big open space so that I can put what the first equation tells me y is. It is 3x minus 2. I then solve this as we have solved all of the equations that have one variable. Distribute the 3. Combine like terms. Isolate the x by first adding 6 on both sides and then dividing by 11. So I'm halfway there. I've got x. However, remember this is a point that I'm solving for, so I need the second half of the point, the y. So I take my first equation, since it already has y alone. And now that I know what x is, I'm going to substitute that x value in. So I've got 3 times 1 minus 2, which is 3 minus 2, which is 1. And then again, because these are two lines, and if I graph them, they would intersect in a point. My answer is a point. So I write my answer as a point, x, comma, y.